Welcome to your first video lesson for grade 12 advanced functions. Unit 3, lesson 1, we're going to focus on dividing polynomials. Okay, let's think back when you did long division just with numbers in elementary school. How did you approach that? 172 divided by 5. So we would have 5 divided into 172. Now 5 divides into 17 3 times. So 5 times 3 is 15. And then we would subtract. 17 minus 15 is 2, bringing down the 2 here. And then 5 goes into 22 4 times. 5 times 4 is 20. Subtract, and we're left with a remainder of 2. Now, before we take a look at what those numbers mean, let's go over a little bit of terminology. I might be using these words later, and they come up in the example questions as well, so you got to know what they mean. So the 34 here, that's the quotient. The 172 is known as the dividend. 5 is the divisor. And of course the 2 is the remainder. All right. So how can we write this in a different way? So we know that 172 divided by 5 is going to be equal to 34 plus 2/5 of the remainder. So 2 over the remainder divided by the divisor. All right, so now if we wanted to approach this using variables, what you see more likely in high school, now this question here, 4x minus 7 divided by 2, most of you would probably just look at this question and say, okay, well, I know how to do that. It's just 4x minus 7 divided by 2. You'd probably write it like this, and then just use the property of dividing monomials from grade 9 and simplify this to 2x minus, and then 7 over 2. Well, could we approach this division question in the same way that you would approach it in elementary school? And the answer is yes, we can. So let's do this exact same question using this form here of dividing into. So we're going to take 2 and divide it into 4x minus 7. So above the linear term, what needs to be multiplied by the 2 to make a 4x? Well, I need to multiply it by 2x. And so 2x times 2 is 4x. Subtract, just as you would with numbers. 4x minus 4x is 0. Now bring down the next piece, which is what you would do if, well, we did it over here with the 2, sorry, we did that already. So now 2 goes into negative 7, minus 3 times, leaving me with minus 6, and then subtract again, and so negative 6 minus negative 6, negative 7 plus 6, is just negative 1. So we could write 4x minus 7 divided by 2 equals 2x minus 3, and then minus the remainder over the divisor, which if we really wanted to, we could simplify this to 2x minus 3.5, which of course is the exact same thing as 7 over 2. All right, so both ways, obviously this is not the efficient way to do this. You would never go about it this way. We would just go through it the way I did it up here. However, this shows the process if we're doing it with more complicated questions. So the next one is a more complicated question. So let's take a look at example 1. Long division with a binomial divisor where the remainder is going to be 0. So I'm already letting you know that the remainder is 0. Sorry, that's not very exciting for you, but here we go. X plus 2, so determine the quotient of this expression, which is a cubic, divided by this binomial, which is a linear binomial. So we have x plus 2 has to divide into, sorry, these are not perfect lines, but you know, I'm still learning with this program, plus 14x plus 8. All right, so we want to look at the first part of your binomial, and you want to think, okay, how am I going to make x become x cubed? Well, I'm going to make it become x cubed through multiplication of x squared. So since it's going to be a quadratic term, you want to write it above the quadratic term. So this is more for mathematical form. You want to line it up. So x squared times x is x cubed. Now 2 times x squared is 2x squared. So it's just distributive property, but you kind of have to do that in your head. Subtract 7 minus 2 is 5x squared. Now we're going to bring down the next term, 14x. Okay, so then you ask yourself, how do I make this x become 5x squared? Well, through multiplication of 5x. So since 5x is a linear term, it gets written above the linear term here in the dividend. So 5x times x is 5x squared, and then 5x times 2 is 10x. Write this here, subtract, and we end up with 4x, and then finally bring down the 8, and now you ask yourself, how does the x become 4x? Through multiplication of 4, and the constant terms line up here. So it's 4x. And then 4 times 2 is 8. And as expected, because you were told, we had a lovely remainder of 0. So now, and this is one of the skills actually that you'll use for this unit, is if I wanted you to fully factor x cubed plus 7x squared plus 14x plus 8, you can now factor it completely, because you know that, and I've just lost my pens, so I'm going to try to get green here. So now you know that x cubed plus 7x squared plus 14x plus 8 equals, it's got to equal the binomial that you've divided into multiplied by the quotient. So the divisor multiplied by the quotient. And if you notice, the quotient is just a simple trinomial that can be easily factored by product and sum. So 2 numbers multiply to 4, add to 5, so 4 and 1. So this will be x plus 4, x plus 1. And for what we've doing with what we've been discussing now, you know that this is, well, you knew before it was a cubic, but you can clearly see the roots, and you should be able to sketch this now that you have the roots. Okay, here's the next example. Example 2, missing a term. So if you take a look at the dividend here, we have 3x cubed minus x plus 5, so it's actually missing the quadratic term. So just the point of this example is, how do you write it when there's a missing term? And it's exactly how you would expect. You have to put in a placeholder. So when I write it here, it'd be 3x cubed. Now the x squared term is missing, but I have to include it. It'll just make things a lot neater when you go and do your subtractions underneath to have that there. Minus x and then plus 5. All right, so you ask yourself, how does the x become 3x cubed? It's through multiplication of 3x squared. And so there it is. We have our quadratic term in our dividend, so we can line it up. So it's going to be 3x squared. So I get 3x cubed minus 3x squared, subtracting. So 0 subtract negative 3 is positive 3x squared. Bring down the x. So how does the x become 3x squared? Well, it's got to be multiplied by positive 3x. So I end up with 3x squared. And then 3x times negative 1 is minus 3x. Subtract. You get 1 plus 3x, which is 2x. Bring down the 5. And then lastly, we have how does x become 2x multiplied by 2. And we get 2x minus 2, and then we subtract and we get 5. Subtract negative 2 is positive 7. So we could write our answer here, 3x squared. Sorry, pardon me. Let me erase that. That's not 3x squared. 3x cubed minus x plus 5 divided by x minus 1 equals 3x squared plus 3x plus 2 quotient plus the remainder over the divisor. Now this form is going to be important in calculus because this is the way we're going to have to write things when we look at oblique asymptotes and limits. So you have to get used to writing it in this way. So that's the point of doing it that for now. All right, last example. No, this is not called missing a term. I must have not changed that. So let's just ignore the fact that it says missing a term. This is just supposed to be a more complicated approach with a quartic and a quadratic. So it's actually not missing a term. It's just a more complicated quadratic example. I'm not sure why it says that. Probably because I cut and paste and I was lazy and I forgot to change it. So let's do x squared minus 4 divides into x to the power 4 minus 15x cubed plus 2x squared plus 12x minus 10. And really, this method of dividing will work with any question. You can make up your own question, do any polynomial, and divide it into any polynomial, like a binomial into anything, a monomial into anything, and this method will work. So if you want to practice, you can make up any question and just try it and see how it goes. So we have x squared dividing into x to the power 4, so multiply through, oops. Okay, what did I do wrong there? I was supposed to line it up with the quadratic term, so here we go, good form, x squared, so x to the power 4, and then when I multiply it by the 4, that's going to give me a quadratic term, so I actually don't have the cubic, but negative 4 times x squared is negative 4x squared. All right, subtract, and we get negative 15x cubed. And then 2 plus 4, because it's a minus and a minus, is 6x squared. And then how does the x squared become negative 15x cubed? We multiply it by minus 15x, and again, lining up the linear term there. So we get minus 15x squared, sorry, x cubed. And then minus 15 times negative 4 is positive 60x. And what did I do here? I made a mistake. Let me erase that. What's the problem? When I wrote that, I realized that I had lined up the linear term with the quadratic term, which isn't right. I have to line up the linear term with the linear term. So I need to bring down the 12x. I actually don't have a quadratic term, but I do have a linear term. So I got to write the plus 60x there. Sorry about that, but that's okay. You see the mistake? And you won't make that same mistake. So here that's 0, this is 6x squared, and then we end up with negative 48x. Bring down the negative 10. And how does the x squared become 6x squared? We multiply it by 6. And so we get 6x squared. There's no linear term, so 0x. And then minus 24. Subtract. And you get negative 48x plus 14. So the result is when you take x to the power 4 minus 15x cubed plus 2x squared plus 12x minus 10, and you divide it by x squared minus 4, the result is a quadratic x squared minus 15x plus 6 plus the remainder divided by the divisor. And that's it. Hope you enjoyed your first video lesson, and we'll talk about this on Tuesday. Have a great weekend.